Good morning, grade 8s, and today we're actually learning about index laws. Okay, so when we're working with index laws, it's important to know the important components of when we're looking at index laws. So say I have something a to the power of x. What does the a stand for? What is the x? So when we're looking at our a, that is actually known as our base. So it's important to use the correct terminology as well. What is our x? Well, you may have heard this to be known as the power or index. This can also be referred to, so the whole term together can be referred to as a to the power of x. Okay, so let's say we had a base of 10 and it was to the power of 2. What does this mean? Well, our power is important because it tells us how many times the base of 10 is being multiplied by itself. So what does that exactly mean? Well, 10 to the power of 2, or 10 squared, is equal to 10 times 10. So the base itself is being multiplied 2 times by itself, as you can see. What about if we had a question that was 10 to the power of 2 times 10 to the power of 5? How would we work out a question like this, or an expression like this? Well, what we can do is, with the new information we've just found out, we know what 10 to the power of 2 is. That equals 10 times 10. So what will 10 to the power of 5 equal? Well, we know that the base is being multiplied by itself 5 times. So we write out our base 5 times. It does not mean 5 times 10. That's not right. It means that the base is being multiplied by itself 5 times. Okay? So with that knowledge, we can actually add up all our 10s and find out what our new power is. So our base is 10. But what is our power? Well, we've got 1, 2, 3, 4, 5, 6, 7. So we've actually got, our answer is 10 to the power of 7. So where did this 7 come from exactly? Well, we know that our power of 2 here means that our base of 10 is being multiplied 2 times by itself. And we know that our base of 10 to the power of 5 means that base is being multiplied by itself 5 times. So what we can actually do is add these two powers together to get our final answer of 10 to the power of 7. This actually can be turned into a rule from what we've just learnt. So say we had a base of a to the power of x, and it's important that it's to the same base. We can actually add these powers together if they are the same base. Either a, or like in our last example, it was 10. So let's have an example of a, our base, to the power of 3 times by a to the power of 15. Instead of actually writing out 15 a's, which would take us a while, our working out should look like a 3 plus 15, as we demonstrated from our new rule. So what is 3 plus 15? Our answer is a, our base of a, to the power of 18. What about if we had an example like this? A to the power of 3, b to the power of 2, times by a, b to the power of 3. Okay, now we're looking at two variables, aren't we? We've got a as one base, and we've got b as a second base. So what should we do first? We should group like terms. So we should group our a's together, our two bases here, and we should group our b's together. So we should have a to the power of 3, a to the power of 3, and it's important that this a alone is actually to the power of 1. Okay, so it's important to add that 1, so you know you're plussing it by 1. Also, we need to group our b's together, so we have b to the power of 2, and we also need to plus it by the power of 3. So what does our answer equal? Well, it's a to the power of 4 and b to the power of 5. Okay, so you can see that it's now important when we've got an extra variable or an extra base that we start grouping our like terms. Say we have a question that looks like this. 3a b to the power of 4 times 2a b to the power of 18. This is getting a little bit more complex. Let's first put in our 1s for our a's, so we make sure that we know they're to the power of 1. Let's also look at our variables. What are like terms? Well, our 3 and our 2 are constants, so we can actually times them together. They're like terms. What else is like terms? Our a's are like terms, and then our b's together are like terms. So firstly, let's put our like terms together. So 3 times 2 is a like term. Then we have times by a1 plus 1. So a to the power of 1 plus 1. And we've also got to do our b's. So we have b, and it's to the power of 4. But we need to plus it by our 18. Okay, so what's 3 times 2 is 6. What's 1 plus 1? Well, it will be a to the power of 2. And what's 4 plus 18? That will be 22. So can we make this more simple? Can we simplify this? Yes, we can. Remember that these are times in between here, but we can actually just simplify it like so. So 6a to the power of 2, b to the power of 22. So when you come across questions like this, make sure you're grouping like terms and you're showing all you're working out. Congratulations, you've just learnt the first index law.